This is the documentation about Bolt12. I hope it's visible to everyone. All right. So today we are going to cover Bolt12. So I'm assuming everyone here knows what are bolts. So every protocol has some rules on which it works. So for the Lightning Network, all the ru- all the protocol rules have been nomenclated as Bolt. Its full form is Basis of Lightning Technology. So they wanted it to name Bolt, and they made up any full form that they could of this word Bolt. So there are many bolts which are inscribed into the Lightning protocol. The 11th and the 12th one deals with the invoices. So currently, wait, yeah, this is the main repository where all the bolts are derived, and yeah, this is the repository where the rules are written and all the things from here. Yeah, sure, sure. It's this one. As you can see, there are these different files named introduction, messaging. This is Bolt2 peer protocol. So each of these files deals with their own topic of discussion. So this one deals with how the messages are serialized and sent over the network. This one says how the handshake happens, the transactions, the routing, the on-chain dropping off channel, and all of those things. So currently, the Lightning Network deals with micropayments, right? As you might all know, we are here to send payments like quickly because on-chain payments could take much time and much fees as well. So what happens is, uh, if I compare it with a credit card or the traditional fiat system, so imagine you want to buy a coffee every morning, or you want to get a subscription of Netflix. So what you do is you fill in your credit card details into the website, the expiry date and the CVV and all of those things, and then the vendor that you're trying to get the service from, uh, it pulls the money out of your card recursively, like every month or every day, and or whatever you choose your recursive limit to be. That's not how Lightning works. So in Lightning, uh, you have to fetch an invoice. That invoice is currently known as Bolt11. So if you look at this one, the payment encoding. So if you want to buy a service from any vendor, you go to him and you tell him to give you an invoice, and then you pay that invoice. So it's a push mechanism. So for the traditional fiat system, it's generally a pull mechanism, and for Lightning currently, it's a push mechanism. Now that this Bolt 11 has been it was developed not it's not a very well thought invoice protocol. So it was developed just to create test transactions. But as we scale, we would need many features to basically scale Lightning for post hyper Bitcoinization world. So one of the major limitation of Bolt 11 is all the invoices that you use are not reusable. So you can't. I hope I'm audible and the screen is visible as well.
Yes, you're audible and the screen is visible as well.
All right. So the invoices are basically not reusable, and there's a good reason behind it. So whenever you route a transaction on the Lightning channel, on the Lightning network, there is a pre-image which has to be passed over to the peer that you got the payment from, so that you can redeem your payment and pass it over to the next one. So each invoice has a unique pre-image, which if exposed to someone in the route can steal your funds. So one of this is the reason why the Lightning invoices right now are not reusable. Second, there's not a uh, good way to prove the vendor that you are the one who has paid the invoice. So when everyone in the route gets the pre-image, uh, they can basically pre-image is a proof that the vendor got the money, but it's not a proof who paid it. So that's a limitation of the Bolt 11 invoices. So I think you guys can think of it yourself. What problems can these two things arise? So imagine you are a vendor who runs an e-commerce a shop or something. So you can't inscribe a payment QR code on your website so that people can recursively use it and pay you. And if you're a customer and you got bad service from someone, you won't be able to claim refunds or do anything because it's to prove that you have paid the invoice is not a very trivial thing for Bolt 11. These are the limitations of Bolt 11. This one here is the protocol. It has not been merged yet. As you can see inside the bolts repository, we have only 11 bolts. So the main contributor, the Lightning developer at Blockstream called Rusty Russell, ideated this Bolt 12, uh, which is a scale-up version of Bolt 11. So this is the spec of Bolt 12. You can get this from this repository. Wait, I'll paste the link of it in the chat. So you can clone this repository and or you can just get this file called the Bolt 12 HTML. Uh, and there is a website on the internet called bolt12.org. Bolt12.org. So this is a website which basically tells the use cases and uh, all of those things about Bolt 12. So you can visit this bolt.org to see how this works and what all are the wallets that support Bolt 12. There are developer docs as well. And the spec, it basically redirects you to the GitHub repository where the pull request is posted. But I don't like the UI of GitHub much, so I prefer cloning the repository and running the site locally here. So yeah, this is Bolt 12. So as you can see, the first section of it starts with the limitations of Bolt 11. So if you have any doubt, feel free to interrupt and ask, throw away all the questions
So
that
the
you have.
biggest benefit for Bolt 12 is permanent invoices. That's it, right? Permanent address, lightning address.
That's a major benefit of Bolt 12, but there are other features as well, which we'll see while going through this document.
Okay.
Yeah. So as we have discussed, the major limitations of Bolt 12 were you are not able to use the invoices again, and the proof of payment is not good in Bolt 11. So what Bolt 12 proposes is it creates an additional layer over Bolt 11. So this is so Bolt 12 has three kinds of messages. It's called Bolt 12 offers, invoice request, and invoice. So the UX flow of Bolt 12 would be something like this. So a merchant publishes an offer. So the UX flow of Bolt 12 goes like this. So a merchant publishes an offer on a web page or anything. So this is the direct advantage of Bolt 12 because if you were to publish a QR code for each invoice in terms of Bolt 11, it would have to reload every time you reload the website. And if two people paid the same invoice, it's a huge security risk because some of the routing nodes would recognize that this is the pre-image of the invoice and they could steal your money. So it's not suggested to pay any invoice for more than one time. So for Bolt 12, the offers are static. So the merchant publishes a QR code. Now the user scans it and creates an invoice request message. And this invoice request message in turn gets a reply from the merchant with an invoice, with a unique invoice. And then the node can pay that invoice. So this works like an additional layer on top of Bolt 11. Hello. All right. So this is just one use case of Bolt12. The other one is the refund flow, which is called the refund flow. So imagine uh, uh, you are at an ATM, right, and you want to get money from it. So it would have an invoice request QR code on its screen. You scan it, and then you send it an invoice over the Lightning Network, and then the ATM pays your node the money. So this is how the refund flow works, and this is how the merchant flow works. Now, one of the advantage of Bolt12 is the signatures are so in Bolt11 you sign the whole payment, right, that you do. So in order to create a proof of payment, you would have to reveal all the information that is encoded inside the invoice, right? But Bolt12 follows this one, the BIP340 signature scheme, which is the Schnorr signature. So if some of you are aware about it, so it's a tree that you sign. You sign the Merkle root of the tree that is constructed using the information inscribed in the transaction. So this is how this works. So you can create a binary tree from all the information that you want to encode inside the transaction using
Aditya,
yeah.
so there is a question by a participant,
Mhm.
Cyber, in the
Mhm.
chat section. Is it possible for you to open the chat section and read the question?
Yeah. Isn't Bolt12 just a HTTP server to resolve Bolt11? No. No, I think you're confusing. Even LN URL doesn't do that. So, no. Bolt12 is a separate protocol feature for the Lightning Network. I think this question arises from the QR code that was posted inside on our Discord by HRF, if I'm not wrong. So Bolt12 is not an HTTP server. It's a message protocol inside the Lightning Network to deal with payments. It's a why not use stages for this kind of event that allows the user to raise their hand to speak. Yeah, I think since we are not, the number of participants is not very high, you guys can just unmute your mic and throw away all the questions that you have. Can I continue?
Yes, Aditya, continue. Just a reminder for the participants, if you have any questions, please feel free to unmute yourself and ask a question midway.
Yeah. Just to reiterate, Bolt12 is not HTTP server. LN URL is basically it hits an HTTP server to grab the invoice, but that has some privacy issues because you are not on the Lightning Network and you're hitting up an HTTP server using the Internet Protocol. So yeah, that is a layer up scale solution of invoices, but Bolt12 once Bolt12 comes, LN URL could be of no use, basically. Yeah. So one of the advantage of Bolt12 is while creating a proof of payment, the payee can basically decide what information to reveal and what not to reveal. So what happens is you
We'll have
sign
to
the
zoom,
root.
Aditya.
Sure.
Yeah, perfect.
Yeah. So what happens is you create a signature from the root of the tree, which is constructed from the TLVs that are encoded inside your payment. So if you want to create a proof of payment, you won't have to reveal all the leaf nodes, that is L1, L2, or L3. You can just reveal one of these and the path uh, till the node. So that would be enough for you to create a proof of payment with privacy. You can read about this kind of signature in BIP 340. These are called Schnorr signatures. They have many features over the signature scheme that is used currently in Lightning Network. So this one's
Aditya, what's a
also
TLV? What's a TLV?
TLV is a serialization format for a message. It stands for type, length, and value. So imagine if I want to send you some data over the internet. So on the internet, it transports as numbers, right? So you won't be able to figure out anything from numbers. So the TLV format says that the first a constant number of byte would suggest the type of the message that I am sending to you. So imagine if I want to send you a vector. So I would, and this vector would be number of students in the workshop. So I name it type 1, and then I create another type 2, the number of coffee sold in our workshop. So if I send you a blob which starts with 1, you would immediately know that this type refers to the number of students. Then I send you the length of the array. So imagine if it on the first workshop we have 5 students, and in the next workshop we have 10 students. So I would append 5 to it, and then there would be 5 numbers appended to this blob. So just by seeing those numbers, you would know what this blob of data that I sent you meant. If I sent you a blob which starts with the type 2, you would know this tells about the number of coffees that are sold on each day of our conference. So, and then the length would give you the length of the vector, and then the value would be of length, the L. So this is how you serialize data basically.
Right, got it. So is there a place where we can find all the types of data that can be transmitted over the
Yeah.
Lightning Network?
Yeah, so those are inscribed inside this Bolt repository. So if you open any of the Bolt, it would have a Lightning message, most probably. This open channel message. So as you can see, these are the TLV streams that are appended, and these basically define the Lightning messages which we sent through the network. So whenever another node decodes the message and sees type 32, it would know that this is an open channel message, and then it would deserialize all of this stuff according to the protocol. So
Right, got
every
it.
message is encoded in TLV.
Right, thanks.
Yeah. So, yeah, the big advantage of Bolt12 is you can create a proof of payment, and you won't have to reveal your personal information. Yeah. Hello. All right. So you won't have to reveal the entire transaction to the vendor in order to create the proof of payment. You can just selectively choose what to reveal and what not to reveal, and then give the vendor a path to the root. So then they would know that this particular person paid the offer. So it solves two big things. It creates static invoices, and the proof of payment is also is also solved, which is not very trivial in Bolt 11. Yeah. So this is the first message type in Bolt 12. It's called the offers, and this is the one that is called the static invoice. So as you can see, this is the message. This has offer chains. It gives the chain hash for the like what blockchain are we using? Are we using testnet, redtest, or the mainnet? Then offer metadata, the currency. Yeah, there are some small modifications in Bolt 12 as well, which basically scales up the feature. So you can pay using any currency that you want in Bolt 12. So you can create a static invoice of 5 USD per month. So that is also allowed. You don't have to write number of sats always. You can choose a currency, and then the wallet could basically fetch the details of the currency through some exchange, and it would average it out and pay only the amount that you want to pay a user. So you can write 5 USD, 10 USD, or 100 rupees, 200 rupees. So that is possible. You can create recurring invoices as well. So you can basically create a Bolt 12 invoice which sends which basically receives a payment every day, every month, every week. So you can uh, set the frequency of that as well. So if you scroll down in the protocol, you can basically
I have a question. By
yeah.
recurring offers, you mean that offer can receive a certain payment at a predefined period of time. right?
Yeah.
So, but the sender needs to
So
initiate the payment, right? How will the offer pull the money from the sender's wallet?
uh, it all happens under the hood. So you create a message using the offer. So the vendor would create the offer, and then the payer would basically create an invoice request every time, and then it would get the invoices from the vendor, and it would pay it uh, individually every month or that. Since
Okay, so
since
whatever is the
Lightning is
predefined time,
yeah
at that time
yeah
the vendor will send an invoice.
yeah exactly.
Okay, all right.
Yeah, we'll create a Bolt12 recurring invoice in CLN in some time. So if you want to,
I have a question. Can I ask?
yeah, go on.
So can one node have multiple Bolt12 offers?
Yeah, you can create as many Bolt12 offers as you can.
Okay.
And if you guys have some information about Bitcoin addresses, it's generally not suggested to use a Bitcoin address for multiple payments because it reveals it basically decreases your privacy if you reuse your Bitcoin address. This is not the case for Bolt12. You can create n number of invoices using a single offer, and it would
No,
not
no,
decrease your privacy.
I'm not asking about multiple invoices. So
Yeah.
let's say, I'll give you a use case scenario. Let's say I'm
Hmm.
running a shop and
Hmm.
I want to have a separate Bolt12 offer for my
Hmm.
online sales
Yeah.
and another for my offline sales.
Yeah.
And both should be connected, both should be generated from the same node. So I'm only
Same node.
running one node and I want to have two
Yeah.
Bolt12 offers.
Yeah.
And
Yeah. That's possible. That's
okay.
possible. You can create multiple offers from the same node of different amount, different currencies, and all of those things. You will have to set the description of what it does. So that's not an issue. Uh, and using a single offer, you can create multiple invoices as well. And those, it could be each user can create a proof of payment of their own using the same offer. So those are the issues that are solved with Bolt12.
Okay.
If you want to see what each of these fields mean, you can read the section below the messages. So just to give you a brief here, the offer node ID gives you the node ID of the vendor. There is also a way to basically hide it if you want privacy because Bolt12 propagate using the onion message protocol. So there's something called blinded routes. You guys can research about it, what it does. So it basically doesn't reveal your place, reveal your position on the network. And it would propagate, the payment would reach you, but the payer or anyone else won't know what are your direct channels and all of those things. So, uh, all right. The entire offer is required. Yeah. So now using this offer string, which starts with LNO. So every invoice that starts with LNO and then a one is an offer string. Using this LNO invoice, we can create the payer would create an invoice request. So, and the invoice request starts with LNR. It would be mentioned somewhere here. Yeah. So this is the LNR message, which is constructed using the offers. As you can see, uh, there would be a section for recurring payments here. Uh, Description feature seconds. All right. I think recurring payments are dealt. Okay. So when this particular web page was written, they didn't add recurrence. But right now, the latest version of Bolt12 have recurrence in their payment as well. So for the latest copy of uh, the spec protocol, you can go to bolt12.org and go to read the spec. So it would direct you to the latest pull request. It's an old project basically. This has been ideated like 3 or 4 years before. So a lot of development has happened since then. Where is it? Here. Yeah. So using the offers, the vendor would create an invoice request and it would send an invoice request. And then a reply to this invoice request would be the invoice. Here's the invoice. And then the user would pay the invoice, and that's how the payment goes through. Now, the signature, as we have already discussed, the advantage is it uses BIP34 signature, so you won't have to reveal all of your transaction data in order to create a proof of payment. You can choose which information to reveal. There is a payer key field inside invoice request messages, which is used to create the proof of payment in general, but you can choose something else as well. And for the ATM flow, for the refund flow, the vendor basically would publish the invoice request message. So when I scan the invoice request QR code from my wallet, I would send an invoice to the node ID, and then the particular node that the ATM operates on would pay that invoice. So this is how the ATM flow works.
So Aditya, I have one question. Like, I mean, the 340 signatures are Schnorr signatures. We use them in Bitcoin as well, and we use them for tapping transactions. And
Yeah.
we have a concept of tap scripts, right? We have Merkle trees.
Yeah.
Each tap script is a leaf, and we only reveal
Yeah.
the script which we want to execute while making the payment, and everything else is hidden, right? So
Exactly.
I heard you saying twice that you only have to reveal a certain amount of information and not everything. Can you elaborate a little more on that? Like, what information are we hiding? What are we showing? What's the use case?
Wait. If you look at the messages, if you look at the invoice, right, there are many information that you basically won't want to reveal. Maybe maybe the description or anything that you want to hide from the general world, right? So the 340 signatures are created in this way. So using each of the field, you create the leaf node, and then you create a tree which converges at the root, right? And you won't be able to uh, guess any data in the leaf using like just by seeing the root itself. So you sign the root. Once you sign the transaction and you send it to the vendor, and if the vendor says, please give me your proof of payment if you want the refund, so you can choose to reveal either of any of the field that is encoded inside the leaf. So imagine if I don't want to reveal L1 to the vendor or L3 to the vendor, I could just choose this one, L2 and L2 nonce. I could give all the hashes that are generated from L2 L2 nonce to the root, and then using it, the vendor would know that yes, this particular signature was created by him only, and I would not be I won't have to reveal all the leaf nodes that are inside the tree. This is a very layman description of how these signature works. There's obviously much greater detail and depth to what happens.
Right. So, what information could L1, L2, and L3 be? Like in a real world, what could be any three pieces of information that we would have in L1 and L2 and L3?
Okay, so there could be anything. You could have used imagine you don't want to tell the world why you paid someone this amount of money, right? And L1 could be the description or anything. So and the description could have the purpose of your payment. So you won't have to reveal that if you don't want to. It gives you the freedom.
Right, got it.
In
Got
Bolt
it.
11, to create a proof of payment, you would have to reveal full uh, the full transaction.
Got it. Got it. Fine.
Yeah. So now let's hop over to the core lightning and see what Bolt 12 looks like. So currently Bolt 12 is an experimental feature in Bolt in Core Lightning. So in order to use the APIs which deals with Bolt 12, you would have to run your Lightning node using experimental offers flag. I hope it's usable. Wait, I'll zoom it in. Yeah.
Okay, I have a question. So
Yeah.
for Bolt11, you can
Yeah.
set an expiry date for an invoice. And I understand that you said Bolt12, you can make it to be static QR code.
Yeah.
So I wanted to know if it's possible to be able to set an expiry time for the offers that someone can create. Is it possible?
Is it possible to create a static time? Is that what you're asking?
Yeah, an expiry time.
Yeah. You can. There are flags inside the offer messages, like the single-use flag, using which you can basically create a non-reusable invoice. You can also create an expiry time for it as well. So your node won't reply to the invoice request which is constructed using the offer which has a life which has an expired lifetime. So that is possible as well. So you use this flag to run your to basically enable your node to create lightning to Bolt12 offers and to decode it on your node. Yeah. So there's this API reference for the code lightning. It's on doc.codelightning.org. You can search for code lightning documentation and it would redirect you to this page. It has all the description about all the APIs that are used for code lightning. So currently we want to generate offer, which is the Bolt12 invoice. So uh, there's an API for this called lightning offer. Here, command for accepting payments. So to create an offer, these are the parameters that you can set. All the parameters that are inside the square bracket are the optional parameters. So as you can see, you would have to set an amount for creating the offer. The amount basically reflects the price of the item that you're going to sell. The description, what it is for, the issuer, basically about your name and all, label, quantity max says stock. So imagine if you have uh, uh, okay, so you're selling books, right? And you had 10 books and 9 books are already sold. So if two more people create invoices using the QR code, someone would pay for a book which is not in stock. So you can set the quantity max to the available stock in your inventory. The expiry time. Someone asked me about that. Like just that. The recurrence period that you want to set. So as you can see. An invoice is expected at regular intervals, so it accepts seconds, minutes, hours, days, weeks, and months or years. Uh, and this one's the expiry time for the offer. Time the offer is valid until. Uh, Quantity max is the amount. Basically, just a second. Yeah, the stock of your inventory. So now let's hop onto the terminal and create an invoice. we'll create an invoice of 10,000 sats and we would set the recurrence to 1 week. Will this work? All right. Okay, so it's not offered. Offer. Yeah. So as you can see, it gave me a Bolt12 string. This one's the invoice of which you can create a QR code and publish on your website or do or a T-shirt maybe to accept donations. And on the if we have a look inside what's encoded here, so your wallet under the hood would decode this string. So let's decode and see what goes over to the payer. Yeah, so the offer ID is the offer node ID, I'm assuming. So it gives the address of the vendor where you will have to send the payment to. The offer chains, it says the chain on which the vendor would accept the channel. So this one's the the block hash of the Genesis block of reg test. This is the amount. This is the description. All right. So the recurrence is not, I guess, it's not set valid. I must have made some spelling mistake here. This one's not the description because there's a separate field for recurrence. And this one's the issuer node ID. Yeah. Yeah. So this one's the node ID from which the offer has been issued, and the valid says that it's been serialized and all the things inside it are correct. To have a look at how this is serialized and deserialized, like uh, internally, there is a repository on Rusty Russell's GitHub. You can search for the repository. If any of you know JavaScript, like basic knowledge of JavaScript, you would be able to make sense of it. So I worked on it like 3 years back. This was my entry point into the Lightning Network. So I created a library to decode Bolt12 invoices and propagate it on the Lightning Network using the Tor protocol, which is called the protocol is called the noise protocol. So if you go to the index.js, so yeah, the commented out lines, if you enable it, it calls the functions that are supposed to be called to decode the invoices. So this one's for fetch invoice request. There would be a function called decode. Yeah, this one, the decode function. As you can see, this through like this gives a step by step of how the LNO string that you see on the terminal here is decoded into this JSON. And if you would have set other parameters as well, it would be reflected in the JSON here. So you would know how basically it is decoded. So as you can see, if the prefix is LNO, we append the type to offers, or yeah. But there's a different parser for different kind of messages. So yeah, this is how this works. And to have a look at how TLVs are encoded and decoded, you can also have a look at this, because this has a function to decode and encode TLVs as well. So yeah, using basically if you use this offer string to pay using any wallet, it would it would send an LNR message to my node, and then in return, I would give them an invoice. So this is basically slower than a general Lightning message, because to send a payment, you would have to basically exchange two messages. But in terms of the UX, this is way simpler, because the user won't have to deal with like creating invoices every time a vendor pays, or a customer won't have to deal with creating a proof of payment by revealing all the information that is encoded inside the payment. So this is what Bolt 12 solved. You can find many podcasts of it on YouTube as well, explaining it in greater depth. So this was just to give you a brief overview of how it works under the hood and what are the problem it solved. If you have any questions, feel free to ask.
Oh. I mean, like, we created a Bolt12 invoice, right? We've done this with
Yeah.
Bolt11 as well. But with Bolt11, what we did is that we had two wallets interacting with each other. One creates an invoice, or two nodes interacting with each other. One created an invoice, and we paid that invoice as well, right? And then we checked the balance, reduced, etc. Everything, we've done that. Is it possible to do that with Bolt12 in any of the subsequent sessions? That we create a Bolt12 offer, and then another node pays that offer, and then we verify that the balance has been deducted from one wallet and has increased in the other wallet. Can we do that interaction of
Sure.
two nodes?
Yeah, but we would have to create channels for it, like on testnet, basically. But yeah, that is possible, because Core Lightnings and almost all the implementation now supports Bolt 12. So yeah, that can be done. Otherwise, you can create a local environment like the reg test, the startup reg test script, and create channels
Yeah,
and
exactly.
yeah,
We did it on reg test for Bolt11.
yeah.
So maybe we can
Yeah.
try it for reg test in Bolt12 in any of the subsequent sessions.
Sure, that can be done. I would have to check for all the APIs that would be used for it. For this. For this. As for, yeah. So there's this test offer which gives you what flow you will have to follow to exchange Bolt 12 invoices. Yeah, I think let's do it in the next workshop. So we'll create channels between two nodes, and then use Bolt12 to create multiple invoices and send the payment.
Right. Yeah, that's
Or
my suggestion. That's okay for mine.
yeah,
Yeah.
or people can, as like just as an assignment, people can try doing it on their own local machine using this function called test offers. So you won't have to run this function. Just read what it like. What are how are these two nodes interacting? As you can see, uh, it the here the L1 L and any number represent the node number that we are calling. The RPC call calls the RPC. As you can see, L1 RPC call offer, and it is setting the parameters to 1 lakh sats, description, issuer test, and all of those things. So you guys can take it up as an assignment to try it out, and we'll before starting our next topic, we can definitely do a hands-on for this between two nodes.
How much time do you think this will take? Will it take an entire session for us to do
No,
this
no,
entire
it would be a 10-minute thing.
Oh, okay. All right.
Yeah. So yeah, that would be a good exercise actually.
Cool. So let's give it a shot on our own. And if we can't make it, then we'll meet in the session and do it live.
Sure. I have pasted the repository links to the relevant uh, websites. Wait,
Where have you pasted?
in the chat. Wait, so first one is bolt12.org. this one's the decoder repository. It has the code for decoding the invoices in Python and JavaScript. And the main pull request, since this is like Bolt12 hasn't been added to the main spec yet, so this is the main pull request which has the latest version and all the specifications that are suggested in the developer meeting. Yeah. So you guys can check it out. If you have any questions, feel free to post it in our Discord channel, and we'll definitely do transactions using Bolt12 before we start the next topic in the workshop.
Okay.
Right.
Final question.
All right. I hope you guys enjoyed.
Yeah. TV Peter, you were saying something?
Yes, I had a final question. I wanted to ask. So, when in Bolt11, when you are using onion messages, onion messages.
Sorry.
Can you hear me?
Yes, I can hear you.
Okay, great. So I was saying that in Bolt12, whereby you exchange back and forth messages.
Okay, so those are, yeah. So basically, Lightning Network is a peer-to-peer decentralized network which runs on a particular port. So to operate on a channel and to do like day-to-day operations, all the nodes interact with each other using the Lightning messages. So all the nodes in the network are connected using either the payment channels, or they are just sharing the gossip. Gossip is basically the view of the network. So using that particular network, we exchange the messages. In LN URL, we hit an HTTP server of the node to get the invoice, which is not very secure. It has its own limitations. But the thing with Bolt12 is you won't have to host any HTTP server for your node or anything. You would just hit the node on the Lightning network, the place where you exchange your basic day-to-day channel operation messages and all of those things. So those all happens under the hood. The user won't have to do anything. From user's perspective, the user would just scan the QR code and the payment would go over. Yeah. Okay. Yeah, this is all under the hood stuff. Yeah.
Yes. So I wanted to ask about privacy. When you are making an invoice, when you are making a payment for an invoice, because those two parties are not in a channel, they often make use of onion messages to be able to make payment. Now, when you have back and forth messages between parties, or probably that's using the same route to be able to send those onion messages, won't it reduce the privacy that is often accompanied with Lightning Network payments?
So the inside the messages you have a parameter called blinded routes. It's developed by T-Best. He's a developer at Phoenix Solis. So it basically, if you research about how it works, is it won't reveal your position of where you are in the network. So you send the messages to the vendor, and you give back a reply path using which the vendor can send you an invoice, and it won't know where you exist on the network. It's called blinded route. We can cover it in upcoming workshop if you guys want. I'll have to read about it as well. I'm not an expert at that, but yeah, this is how it works. So it's your privacy would be intact using Bolt12.
All right, thank you.
Yeah, thank you. Any other questions?
Yeah, yes, I have a kind of question.
Mm-hmm.
So, like, My question is about attacks on the network. Like, can someone use this invoice like to prevent people from like forwarding the payments like a denial of service?
It is possible to create a denial of service attack using, like, if I create an invoice with zero amount, and I propagate it on the network, like uh, many numbers of invoices on the network, it could clog some nodes. But uh, there are preventive methods uh, to basically prevent your nodes from going down. There has been some articles on it as well. So yeah, you would have to see. But yeah, it's theoretically possible to create a DOS attack on your node. But that's possible anyway. If you send like infinite number of any messages on your node, it would clog your port.
Yeah, when you use there are like some applications on for like line service, like they have a email like server like address with a name, with a domain name. Isn't there like a concern for aligning for domains can be seized and they can take control of a domain, even routing, even use the Tor networks, something like that.
No, I didn't get your question. So how would you be able to take control of the domain, like using?
Like the domain name. There are some service they use domains to.
Yeah, those are LN URL. So that's called DNS. So you hit an HTTPS server with an invoice request, and you get an invoice in return. That uses Bolt11 under the hood, and you would have to host a server on your node to reply with an invoice. But Bolt12, if for Bolt12, you won't have to host any web server or anything. You would just need your node ID and your IP address. There won't be any. Some people obviously, yeah.
So the IP address needs to be static.
If you want to connect out, you don't need an static IP address. But if you want incoming connections, obviously your peers would have to know your IP address on which you run your node.
Is it possible to use a onion hidden service for that?
What kind of hidden? You can use Tor. So then you would have a Tor address to get incoming connections.
Also, this better. Oh, thanks.
Yeah, this is how you connect to other people on the nodes. You use your node ID. The node ID is basically your identity on the network, and your IP address is the address on which you can get incoming connections. So even if you change your IP address, it won't change, and it won't do any harm to your node as long as you have the same node ID, which is derived from your node secret. So yeah, the address is used just to exchange messages and all of those things. So you won't be able to get control of any node using the IP address or the Tor address. If you guys don't have any questions, we can wrap this up.
Yeah, no questions from my end. Thanks a lot for the session. And yes, for the next section, my suggestion would be that we can interact between two nodes and make a payment over an offer, a Bolt12 offer, and maybe we can consider as our main topic, we can consider blinded routes.
Sure. This sounds a good idea to me.
All right, then fine. If no other questions, then we can call it the session.
Yeah. I think.
Okay. All right. Thanks a lot, Aditya, and thanks a lot, everybody else, for showing up. Good night.
Thank you, everyone. I hope you had fun.
Yes, we did.
Bye.